So for past year 5, question 1. Given that a function is defined fx equals to modulus x plus 1 minus 2, sketch this graph and hence determine its domain and range. So first of all, I will do the domain and range in order to help us to draw this graph. So for domain of the function, modulus function or absolute function is not our special case, and we don't have any condition from the question given. So we'll go back to general modulus function. It will be negative infinity to infinity because it is not our special case. And then we go for our range. So for range, yes, our modulus function is our special case that we need to see it clearly. When we close this modulus characteristic, we can see outside here we have a negative 2. And this modulus is in positive, so negative 2 to infinity. So this minimum point is included. So our range here, we can see negative 2 in negative 2 to infinity means our V shape is going up. Our V shape is going up. Alright, so now we're going to draw our graph here by referring our domain and range. Our V shape is going up. Our minimum value here, the most minimum value here, y is negative 2. And then the x we can read inside here. We can read inside this modulus where x plus 1. So means x equals to negative 1. When it let it equals to 0, then we find out our x. So x is equals to negative 1. So our graph here, make sure you label your xy axis. And we notice that from negative 1 to negative 2 is our V-shaped graph. So means this point is the vertex of this V. And then when I want to draw my V-shaped absolute graph, we notice that they were going to intersect y-axis. So we have to be careful for our y-axis. We have to go accurate. So when we want to find our y-intercept, we need to calculate when x equals to 0, what is our y-coordinate. So it will modulus 1 minus 2. So it will minus 2. So this is our x-intercept. So it is below origin. So we don't overshoot that. So this is our V-shape graph. So the intersection here is negative 1. Label our intersection. And then we still have another intersection we can find here where x intersection. We find our x intersection here. When y equals to 0, we manage to find our x-intercept. So means that modulus x plus 1 minus 2 will equal to 0. Modulus x plus 1 will equal to 2. Then when we open our modulus, we have two answers. One is positive 2, one is negative 2. So our x here, minus 1, we get 1. This one, minus 1, we get negative 3. So we have y-intercept, negative 3, and y-intercept, negative 1, x-intercept, negative 3, another part at positive here, negative 1. So finally, we label it. This is our fx equals to modulus x plus 1 minus 2. So from here, domain will give you 1 mark and range. So for this graph, it will be having 1 marks for the shape, which is located at quadrant 3. You can see the shape here, quadrant 3. And then another mark, you are going to see your label, which is your x-axis, y-axis, and then your label of fx, and then your intersection, then your origin. So all this labeling, you are going to check one by one. So that's all for question 1.